Dear students, I welcome you in the second lecture from the chapter Linear Programming Problems. In the first lecture, we have seen how to plot lines. We have seen that the equation ax plus by is equal to c represents a straight line. In this lecture, we are going to see how to determine the point of intersection of two straight lines. Algebraically, it means to solve simultaneous equations. So let us see how to find intersection point of two lines. Recall that from first lecture, the equation ax plus by is equal to c represents a straight line. So suppose we have two straight lines. First straight line, it say a1x plus b1y is equal to c1, and second straight line, it say a2x plus b2y is equal to c2. We will have two straight lines, and these two straight lines will meet at certain point. Say this is first line, then second line, and these two lines will meet at point x and y. So how to find these coordinates x and y? This is we are going to see. The formula is this: x is given by c1b2 minus c2b1 upon a1b2 minus a2b1. So formula for x is c1b2 minus c2b1 upon a1b2 minus a2b1. The formula for y coordinate is y is equal to a1c2 minus a2c1 upon a1b2 minus a2b1. This is formula for y coordinate. So once you remember this formulae, you will be easily be able to find point of intersection of any two lines. Even if you solve couple of examples based on this formulae, you will easily remember this formulae. There are other ways to solve simultaneous equations, but we are going to stick to this formula to solve simultaneous equations. Formula is easy to remember once you solve couple of examples. Note that denominator is same, a1b2 minus a2b1, and numerator for x coordinate is given by c1b2 minus c2b1, and numerator for y coordinate is given by a1c2 minus a2c1. So I request you to remember this formulae and try to solve couple of examples based on this formulae. Once you solve this formulae once you remember this formulae, you will be able to find intersection point of any two lines. So in order to illustrate this point, let us see some examples of finding intersection point of two lines. So first straight line which I am going to take is 2x plus 3y is equal to 18, and second line is 3x plus 2y is equal to 17. Thus, we have two straight lines. The equation of first straight line is 2x plus 3y is equal to 18, and equation of second straight line is 3x plus 2y is equal to 17. So what is value of a1 here? Value of a1 is 2. Value of b1 is 3, and value of c1 is 18. So a1 is 2, b1 is 3, and c1 is 18. Value of a2 is 3, value of b2 is 2, value of c2 is 17. So here a2 is 3, b2 is 2, and c2 is 17. We have two straight lines. The first straight line is 2x plus 3y is equal to 18. This is first straight line, and second line is 3x plus 2y is equal to 17. How to plot these lines? We have seen in previous lecture. In case you are not getting how to plot these lines, I request you to watch the previous video once again and see how these lines are being plotted. I'll briefly recall here the procedure. In order to plot lines, you need 2 points, and point on x-axis and point on y-axis. For example, to plot this line 2x plus 3y is equal to 18, point on x-axis will be given by c upon a, in this case c1 upon a1, so 18 upon 2, so that is equal to 18 upon 2, which is equal to 9. So you can see that we are having the point 9 over here. On y-axis, the point is obtained by c upon b. In this case, it is 18 upon 3, which is equal to 6. So here you can see we are having 2 points, 9 and 6. And if you join these 2 points, 9 and 6, you will get this. Similarly, you can plot the another line. So plotting these two lines is not a problem. The problem is to obtain the point of intersection of these two lines. So how to obtain intersection point of these two lines? Let us see the formula. The x coordinate is given by c1b2 minus c2b1 upon a1b2 minus a2b1. Just substitute the values. Value of c1 is 18, as I mentioned, this c1. Value of b2 is 2. So this value of b2, which is 2, that way is substituted here. Value of c2 is 17. So this value of c2 is substituted here. Value of b1 is 3. This value is substituted here. Then values of a1 is 2. It is substituted here. Value of b2 is 2. Again it is substituted here. Value of a2 is 3 and value of b1 is 3. Okay. So substitute the values. On substituting the values, we get 18 into 2 minus 17 into 3 upon 2 into 2 minus 3 into 3. Simplify this. The value comes as 18 into 2, 36. 17 into 3, 51. So 36 minus 51. The denominator, 2 into 2, 4. 3 into 3, 9. So 4 minus 9. Thus we have 36 minus 51, which comes as minus 15, and 4 minus 9, which comes as minus 5. Minus 15 upon minus 5 is equal to 3. So value of x is 3. And geometrically, you can observe this value which we are getting, as 3. This is the value 3. X coordinate is 3 here. Similarly, substitute the values of a1 c2 and a2 c1 in numerator. Note that there is no need to calculate denominator once again because it is already calculated here. Denominator is going to same. So denominator you can keep as it is. Numerator you substitute the value. Value of a1 is 2. Value of c2 is 17. Value of a2 is 3 and value of c1 is 18. Substitute these values. So y becomes 2 into 17 minus 3 into 18 upon 2 into 2 minus 3 into 3. That is 34 minus 54 upon 4 minus 9, which comes as minus 20 upon minus 5, and this is equal to 4. So y coordinate is going to be 4. So this is going to be 4 and x coordinate we obtained 3. So the point of intersection is 3, 4. The answer that we obtained is 3, 4. Value of x is 3 and value of y is 4. What it means algebraically, we solved equation 2x plus 3y is equal to 18, and we solved another equation 3x plus 2y is equal to 17, and the answer that we obtained is x is equal to 3 and y is equal to 4. Y is equal to 4. You substitute these values and check whether this equation gets satisfied or not. We can also verify our answer. So 2x plus 3y, that will be, substitute x as 3, y as 4. So that will be 2 into 3 plus 3 into 4. 6 plus 12, that is 18. So first equation gets satisfied. Similarly, check for second equation. In second equation, substitute x as 3, y as 4. So 3 into 3, that is 6, plus 2 into 3 into 3, 9, plus 2 into 4, that is 8. So 9 plus 8 is equal to 17. Second equation also gets satisfied. So whatever answer we obtain, that is 3 and 4, is correct. In this way you can verify the answer. As I mentioned, there are other methods to solve simultaneous equations. You can use them as well, but it is better to remember the formula so that in case values of a1, b1, c1 and a2, b2, c2 are complex, you can just simply substitute these values and get values of x coordinate and y coordinate. Let us see one more example of determining point of intersection of two lines. In this case, we take value of a1 as 1, value of b1 as 1, value of c1 as 6, value of a2 as 5, value of b2 as 3, and value of c2 as 2. So we now have three equations. A1x plus two equations. First equation is a1x plus b1y is equal to c1, and it is x plus y is equal to 6. Value of a1 is 1, value of b1, value of a1 is 1, value of b1 is 1, value of c1 is 6. value of A2, B2 and C2 are 5, 3, 2. So another equation is 5x plus 3y is equal to 2. As we have seen in previous lecture, we can easily plot these two lines by determining point on x-axis and y-axis. So first line which we have obtained or which we can plot is x plus y is equal to 6. This is first line. And second line which we are obtaining is 5x plus 3y is equal to 2. We have 2 points. Now the problem is to obtain their intersection point. As in the previous example, we simply have to substitute the values of A1 B1 C1 and A2 B2 C2 in the corresponding formulae. So let us see the calculation part of determining x coordinate. The value of x is given by C1 B2 minus C2 B1 upon A1 B2 minus A2 B1. Just substitute the value of C1 B2. So C1 is 6, B2 is 3. Here you can see C1 is 6 and B2 is 3. So this value we are substituting. C2 is 2 and B1 is 1. So substitute these values. We get 6 into 3 minus 2 into 1 upon A1 B2 minus A2 B1. Again substitute values of A1 B2. A1 is 1, B2 is 3. So 1 into 3. A2 B1. Value of A2 is 5. B1 is 1. So 5 into 1. Simplify. Do the calculations. 6 into 3, 18. 2 into 1, 2. 1 into 3, 3. Minus 5 into 1, 5. So 18 minus 2 upon 3 minus 5. That comes at 16 minus 2. 16 upon minus 2, which is equal to minus 8. So we obtained x as minus 8. You can observe that the value of x is minus 8 here. If you drop a perpendicular line here, that is going to be minus 8. Similarly, substitute the values in this formula of A1 B1 C1 and A2 B2 C2. No need to repeat the calculations for denominator part. They are going to remain same. You can see they are same. So denominator is going to be minus 2. Just calculate numerator part by substituting values of A1 C2 A2 C1. That is 1 into 2 minus 5 into 6. That comes as 2 minus 30, which is minus 28 upon minus 2, and that equals to 14. So if you drop a perpendicular line here, that will be 14. So 14. This is value of y and this is value of x. X is equal to minus 8 and y is equal to 14. This is intersection point A, which is having coordinates minus 8 and 14. You can verify that the values which we have obtained are correct. X is equal to minus 8 and y is equal to 14. Just verify whether they are correct, whether these values satisfy the equation or not. You can check minus 8 plus 14 equals to 6. So minus 8 plus 14 equals to 6. First equation gets satisfied. Check second equation. 5 into minus 8, that is minus 40, plus 3 into 14, that is 42. 42 minus 40 equals to 2. Both equations get satisfied and we have verified that the answer that we have obtained is correct. Geometrically as well as algebraically, we have verified the answer. I request you to solve some more examples on finding intersection point of two lines. Thank you.